Listed in the accompanying data table are student evaluation ratings of courses and professors, where a rating of 5 is for excellent. Assume that each sample is a simple random sample obtained from a population with a normal distribution. In Part A, it says, use the 93 course evaluations to construct a 99% confidence interval estimate of the standard deviation of the population from which the sample was obtained. And then Part B, we're going to repeat Part A using the 93 professor evaluations, and then we're going to compare. So when we click on this, okay, you're going to see that we have the course evaluations list and the professor's evaluations list. So in the first Part A, they want us to find the course evaluations list. So we're going to go ahead and then open in StatCrunch, okay? And so what we're going to do is we're going to go ahead and find, okay, the summary stats, okay, for each column. So we're going to find the standard deviation and the sample size for both of them. So we're going to go ahead and select N, and then the standard deviation, and then select Compute. Okay, so let's go ahead and do that. So we're going to copy this into our workbook. Okay, so for the first one, okay, for the course evaluation, we know that our sample size is 93. We know that the degrees of freedom is going to be 93 minus 1, which is equal to 92. And then our sample standard deviation, we're going to round that to, let's say, 5 decimal places, 0.54944. Okay, and then now in step 2, we want to figure out what is the critical values of chi-square on the left and on the right. In order to do that, we got to use our 99% confidence level. So alpha is going to equal 1 minus 0.99, which is equal to 0.01. And then we're going to take alpha and then divide that by 2. So 0.01 divided by 2 is going to give us 0.005. So when we want to find that critical values for the chi-square distribution, which is skewed right, that means in both tails we're going to have an area on the right of 0.005, and then over here we have also 0.005. So this is the chi-square critical value on the left, and this is the chi-square critical value on the right. Okay, so now in order to find the critical chi-square value on the left, we know that the area is going to equal 0.005, and we know the area is going to the left. And then to find the critical value of chi-square on the right, again, we know the area is 0.005, and it's pointing to the right as far as the area is concerned. So we're going to open up StatCrunch to find those critical values. Okay, so we're going to go to Stat, Calculators, and go to chi-square. We're going to put in our degrees of freedom, which we found to be 92. And we're pointing to the left, and now we're going to put in the area of 0.005, and we're going to round that to 3 decimal places, which is 60.815. So that is 60.815. So that's 60.815. Okay, now we're going to go ahead and erase that. We're going to change this inequality sign to be greater than to find the right side. We have our area of 0.005, and then rounding that to 3 decimal places is 130 130.681. So this is equal to 130.681 as our critical value on the right. Okay, so now what we want to do is we want to find out what is that confidence interval. Well, we know the sample size is 93, and we know that the sample standard deviation is 0.54944. And now we're going to go ahead and then use our formula to find the confidence interval. So remember, the confidence interval formula is n minus 1 times the sample standard deviation squared over the chi-square critical value on the right. And then the upper limit is n minus 1 times the sample standard deviation over the chi-square value on the left. So let's go ahead and put that in there. So we have 93 minus 1 times 0.54944 squared over the critical value on the right, which is 130.681. And then over here we have 93 minus 1 times 0.54944 squared over the critical value on the left, which is 60.815. So let's go ahead and use our calculator to solve. So we take 93 minus 1, which is 92, times the sample standard deviation is 0.54944 squared. Divide that by 130.681. And then we're going to take the square root of that. Oops. Second square root of the answer there. And so we're going to round that to 2 decimal places. So we get 0.46 for the lower limit. Okay, and again, we're going to take 92, multiply it by the standard deviation of 0.54944 squared. Divide that by 60.815. And then we're going to take the square root of that result. And rounding that to 2 decimal places gives us 0.68. So let's go ahead and put that in there. So 0.46 for the lower limit. And then I believe 0.68 for the upper limit. And there is our result. Now we need to repeat part A and use the 93 professor evaluations. Well, we pretty much already have that information. Okay, so in this case here, we just need to go to step 3 because we already have the critical values. So for step 3, our sample size is still 93. But now our sample standard deviation is 0.56430. Now we're going to do the same thing. So we're going to use our formula. So we know it's n minus 1, so it's 93 minus 1 times the sample standard deviation squared. So that's 0.56430 squared divided by the critical value on the right, which is 130.681. And then over here we have 93 minus 1 times the sample standard deviation of 0.56430 squared divided by the critical value of 60.815. So let's go ahead and do that. So we take 93 minus 1 is 92, times 0.56430 squared, and then divide that by 130.681, and then we're going to take the square root of that, and rounding that to 2 decimal places gives us 0.47. And then likewise, on the upper limit, we're going to take 93 minus 1 again, which is 92, times 0.56430, square that, divide by 60.815, and then we're going to take the square root of that answer. And then round that to 2 decimal places gives us 0.69. So we have 0.47 for the lower limit, and then 0.69 for the upper limit. And there's our result. Now the question says, compare the results and choose the correct answer below. Well, you can see here that they overlap. So they overlap here, right? And therefore, we would say that the intervals overlap, so the populations appear to have amounts of variation that are not substantially different. So we would say F.